adsorption chromatography. I believe you are aware of this word, adsorption chromatography, right? Yes, so everybody has seen that picture also. That was by mistake. Do you know the name of the scientist who was it? Swin, yeah, and he was a famous, I'll say, I don't know whether some say he was Russian, some he was a Russian, but some say he was an Italian as well, right? So his technique, he was the first one, that is 1903, but actually his research started from 1901. The work done between 1901 and 1903. And can anybody tell me what did he do? What he separated out using the adsorption chromatography?
Pigments from plants,
pigments, xanthophylls or chlorophyll, something like this. This was something what he did. That was the first study in chromatography. Now, when we talk about, that was about the glass column. How the pressure, or I'll say a rapid chromatography picture can start initially. So this is something, the one good thing about this paper was, you can see there is one Indian guy as well, Vishwajit Kale. When was it? It was way back in 19th. So even an Indian guy was there who came up with the, who developed a rapid chromatography
system. You will see two tubings. In general HPLC system, if you have seen, we have only one tube. That is nothing but the pump to suck the solvent from the reservoir to the system, right? But here we have we have two tubings. So if I see the green one, there are two green tubes, two pink tubes, right? So why this two? One is the sensor and the second one is your pump. So sensor will sense how much of solvent is remaining. So if the solvent in the reservoir is less than 70% of the total capacity, it will indicate, it will give you an error.
That is because of CAMAG. I would like to say that, and as a expert in one field of planar chromatography, CAMAG is playing vital roles nowadays also, and we are representative of CAMAG in India since last 40 years. We are here in this field, and we are traders of CAMAG HPTLC instruments, and we are trading in India, Nepal, Bhutan, Bangladesh, Sri Lanka and nearby countries. This CAMAG manufactured in Switzerland, and we are trading it in India. Because I read many research papers, and in that they have written, we have used so and so applicator of HPTLC manufactured by Anchrom. No, Anchrom is not manufacturer of HPTLC instruments. CAMAG is the manufacturer. We are trader of that modules, different modules in HPTLC system. We are trading that in India. So, as a representative of Anchrom, I would like to say something about Anchrom. Anchrom is always research supportive, and if you want to develop any HPTLC method, if you want assistance anytime, if you wanted to perform your own sample analysis, you can anytime call us, contact us. We will provide you the literature for your research work if it is available with us, or if you want any method development, mostly for students and researchers, we are doing it on free of cost, but in case of any more expertise involved, we are taking negligible charges from students. So we are always there to support you in the field of planar chromatography, HPTLC and CAMAG HPTLC instrumentation. So I will show my presentation in this mode itself because it is not moving. It is not
define of particular component. It may be pharmacologically active or it may not. So for identification, there are many things. It is depending on many parameters. For example, separation. So first step is the separation. If the separation is perfect, and after that you have identification and you have further characterization of particular component. And with all these parameters, you can know the particular unknown drug. Without this, you cannot go for further drug development. After you identify the drug and you know all its parameter characterization, then you can go for further study like preclinical research, clinical development. These are the further process. So in first process, HPTLC is very useful, and it may also be used in the further process. So first aim is to separate. Why separation is important? Because if you are working with any herbal samples and you want to identify a particular compound which may have pharmacologically activity with regard to diabetes or other type of problems, so first is to separate that particular compound, because without separation you cannot go for proper characterization, because during elution it may give you problem. So in HPTLC we have one term fingerprint, HPTLC fingerprint analysis. So what do you mean by fingerprint? I will explain this. So it is an electronic image of visual HPTLC chromatograph. How it is generated? It is generated after the separation of a particular sample into a specific mobile phase, and after taking the images in all three different lights like UV, fluorescence.
And it may go a little over 1 hour. I hope you don't mind your one gets get delayed. But I don't know whether you have any other session after 1 hour. After 1 hour. Post lunch. So you can compromise your lunch time. And at the same time, what I wish to do is, the first thing, the question is, why do we need to separate compounds? Can somebody answer that? Why does somebody, I mean, if you look at the sites that I do or you do, we are all working about only one thing. What are we worried about? Why do we need us to purify compounds? I mean, I want everybody to speak at some point of time or the other. We have around maybe 60, 70. Okay, so at some point you all have to speak. Yeah, please.
Get rid of contaminants.
So why do you want to get rid of your contaminants?
So as to get the specific activity of that particular.
Okay, now let's see.
To check the purity of further application.
That's the detection. I'm asking you, why do we require to purify compound in the first place?
To identify.
If that is the case, then why is our job only to do identification? But still, why do we need to identify?
Check the properties and.
So why do we need to check the property?
So that we can use it later for specific purpose.
So without purified compound, you cannot use it for specific purposes.
Minimize risk. Further modification to get a better active compound. Or specific studies. Or identification.
If you purify a compound, then there are chances that we may get a better activity, or that particular component may be responsible for the activity. We can reduce the dose. All these things can.
I agree with you, but I counter that. Suppose if you take natural products, all of you must have done pharmacognosy. Okay, all of you are pharmacognosy also, you know that.
I just wanted to let you know that stem cells themselves can be a model to screen various pharmaceuticals for their toxicity as well as for their several actions on which we can use a human stem cell platform. Just as there is a brand, I mean, we all use branded shoes and all those things. So like that, human itself is a brand which we work. So we work on animals, we work on cancer cell lines, we work on animal cell lines. But now this is another important thing is happening is a human stem cell platform, and that also coming from trash to treasure. That means human tissues which are discarded as a biological waste can be gainfully used to screen the medicines, because you can bring those tissues to the lab. For example, placenta, umbilical cord, amnion, adipose tissue, then dental pulp, because we are located at the dental college. So every day there is an extraction of the tooth. So all these teeth come to our lab and we collect the stem cells from that dental pulp. So all these are the precious treasure of stem cells of a human origin, and nothing can beat human. Whatever say you say true is mouse may not be true in man. We all know that. So therefore, many times we, in spite of having all preclinical studies, the drug fails in the human clinical trials because it may not match all those human factors. Anyway, so the whole thing is, I will not go into all these details, drug marketing and so on, but generally for any drug development there are 3 Ds are important: discovery, development and delivery. And we are always fiddling with these 3 things only. That we have to discover something, then we have to develop it further, and finally we have to deliver. Now every funding agency sees to it that research should not be confined only to sake of research. It should have a translational value.
Your molecules. So you need to avoid this kind of additives when you are doing the method development on those things. Okay? So these are the points which you need to take into consideration along with the method development activities which you are doing for your conventional HPLC analysis. General rule to be followed is like try to optimize the chromatography.
You will get the chikungunya also. One mosquito will give the 2 viruses, and that's what the severity of infection. But what is the impression? Oh, it is dengue only. No, it is not. So we need to rule it out. So we need to understand the ecology. So it's a continuous approach to understand what kind of viruses are circulating throughout, and they find out the suitable environment. Every virus or every microorganism, they propagate in a suitable environment. In the adverse condition, what happens? They go in the hiding area. Like the frog. Where are the frogs now? Samadhi, hibernation. And they will come out when there is a water. So likewise, every microorganism, they are having the capacity to put themselves or change themselves according to the adverse or favorable condition. And depending on the density, we are getting exposed, and then we may have, depending on our immunological power, the mild infection, severe infection or fatal. So microbes are still there with every inhalation. We are surviving because of air. With every inhalation, we are inhaling many tiny particles, which are called bacteria or fungus or viruses. And that's what our immunological vigor is in the circulation. It is getting activated because body has to combat that.
Has same image, but we have to switch from locate to acquisition. For locate, it is used in the microscope, and if we switch to the acquisition, then we can see here image. But we have to do.
So this is black one is a tissue. दिख रहा है सबको? और यहाँ से आपको एक outgrowth दिख रही है. So this is outgrowth of the cells. एक बार cells की outgrowth आ गई, then we have to subculture that cells for our study. तो क्या है कि cells की study करना है तो हमें maximum number of cells चाहिए. Then we can multiply that cells